All right, welcome everybody. Let's continue our journey of pre-calculus, and we will learn about complex numbers today. In the beginning of the course, we talked about, let's see, how well do you remember, or if you need to look back at your notes, what do these notations represent? Take a second and pause the video if you want to try and remember, right? Here we have the natural numbers, here we have the integers, here we have the rationals, and here we have real numbers, right? So we went over the concept of these numbers, and the idea for today is let us learn about complex numbers, and we're going to create this set of numbers, and I'll show it step by step. So to warm up, try and think about this idea. If I said, hey, what's the square root of 25? Hopefully you feel okay that this should just be 5. And why is it 5? Because 5 times 5 is 25. But if I said, hey, what is the square root of negative 25? Well, it's not 5 because 5 times 5 is 25. Is it negative 5? Question mark. Well, let's see. What is negative 5 times negative 5? That equals positive 25. So it can't be negative 5 either. So, feels like we can't do this right now. This has no real number, right? This no real value will allow this to happen. So right now, this seems like a question for us. Just to warm up, what I'd like you to do is try and answer these questions. Take your time, right? Try and go through 1, 2, 3, 4. And yeah, so let's see. Let's see if we try to do the first one. If I have x minus 1 equals 0, okay, so I say plus 1, x equals 1. Here I have minus 1, x equals negative 1. Okay. For this one, there's two ways of solving this. If I said, let me get a black pen. Like, let's say if we had x squared minus 1 equals 0, one thing you could do is you could just add 1 on both sides. And I have x squared equals positive 1. And I could take a square root, and x is equal to plus or minus 1, right? Or what else could you do? You could take x squared minus 1 equals 0, and you can factor it. You could say that it's equal to x plus 1, x minus 1 equals 0. You draw your line, you say x plus 1 equals 0, x minus 1 equals 0. If you solve this, x equals negative 1, x equals positive 1. So that's for the third question. For the fourth question, well, let's see. If I try to do it this way, where I just, let's say if I subtract 1 on both sides, right? So then I have x squared equals negative 1. And if I try and do square root, I get x equals, can I do the square root of minus 1? Feels like it's not 1. And it's not negative 1, so right now we can't do this. And if I took, let's say, x squared plus 1 equals 0, could you factor this? Well, here we factored it as, this was a difference of perfect squares, right? But this, is it x plus 1 like that? If you try and FOIL it, it won't work. And it's not, yeah, this right now is not factorable. You cannot factor this. So we'll come back to this question. We need something to be able to do question 4. So yeah, all right. So here, let me introduce the idea of a complex number and how can we create this set. So let's imagine, what I'd like you to do first is, first have this down, and then also have this down, right? Pause the video, have this down. Okay, so let's say let's pick a number that's not 0, right? Let's pick, let's say 3. If I take the number 3 and I multiply it by minus 1, we're going to say that multiplying a number by minus 1 creates a 180-degree rotation. So let me write that down. Multiplying by negative 1 creates a 180-degree rotation. So what on earth am I talking about over here? So let's say we start at the number 3. And if I take 3 and I multiply 3 by -1, what is 3 times -1? That's equal to -3. So notice that I'm going from 3 to -3, right? That's the idea. And notice that this is a 180-degree rotation, right? Because if a whole circle is 360, half of that 360-degree rotation is 180. And similarly, if I said, let's take -3, like imagine if you're here, and I said, let's take -3 and multiply it. Wait, my bad. Let me get rid of the backdrop over here. Okay, that's better. Let's say if I took -3 and I multiply that by -1. What is -3 times -1? It's +3, right? And what does it do? It creates another 180-degree rotation, and notice we're back to +3. So here, for the sake of today's lesson, multiplying any number by -1 creates a 180-degree, and we'll be a little bit more specific and say counterclockwise rotation. Counterclockwise means we're going this way. Clockwise is this way. Right? So multiplying by -1 creates that 180-degree counterclockwise rotation. Okay. Now here is the question that we have over here. If we take any one of these numbers on the x-axis, and if we multiply it by -1, it gets us to this 180-degree counterclockwise rotation. The question we have is, can you think of a number that if I multiply to, like, let's say 3, it doesn't create a 180-degree rotation that brings me here, but instead it brings me here to a 90-degree rotation? Can you think of a number? If you want, pause the video and let's see. Right? If you said, let's say, if I took the number 3, some common examples I've heard in the past, you said, oh, mister, let's say 3 times 0, right? But notice 3 times 0 is 0, and it doesn't bring me here, it just brings me here. So that doesn't work. 3 times a half, no, that doesn't work. What we're going to do is we're going to make up a number. We're going to create a number that creates a 90-degree rotation, and we're going to call it I. We're going to say that I creates a 90-degree counterclockwise rotation. So, like, let's say if I have the number, let's say if I take the number 3, right? Let's say if I have 3, and I multiply it by this value of I. We don't know what I is. We're just going to say that I creates this 90-degree counterclockwise rotation. If I take 3 and I multiply it by I, it gives us 3I. And what it will do is it'll bring us over here. So notice, what do you think we're going to show as this axis over here? We're going to call this 3I. We'll call this 2I. We'll call this just one regular I. And here we could call this -I, -2I, -3I. And we're just creating this system right now. We're just saying that I creates this 90-degree rotation. Like 3 times I, here I'll show it like this. Right. Here I have 3 times I gives me 3I. 2 times I gives me 2I. 1 times I gives me 1I. And same idea here. Like if I have -1, like if I take -1 times I, it gives me -I. If I take -2 times I, oh, sorry. If I take -2 times I, it gives me -2I. And same idea here. Right? Here it's just creating this 90-degree rotation. Okay? All right, let's continue. Now, let's imagine we have this part over here. What happens if we multiply a point on the vertical line by I? So let's say, for example, I'm at 3i. Let's say I'm over here, I'm at 3i. I'm on the vertical line. And if I take 3i and I multiply it by I, what will it do? It will get me to -3. It's still creating that 90-degree rotation. So this should be -3. And notice that also here, like if I take 2i and I multiply by I, it gets me to -2. And that same idea here, if I'm at I and I multiply by I, it gets me to -1. And this is the magical thing we want to have over here. Notice that with this algebraic equation, that if I have I times I, it's equal to -1. So here what we have is this nice little equation that says, what is I times I? I times I is I squared, and that equals -1. Now if I said, hey, how do I get I by itself over here? What does it equal? How would I solve this equation for I? If I pause the video and try and get I by itself. Right. If I wanted to get I by itself, I would have to take the square root. So if I take the square root of I squared, that gives me I. And notice that if I had the square root of -1, you can't do this. But that's what we're going to call I. We're going to say that I is equal to the square root of -1. And this will be very helpful for solving this over here. That here we have I is equal to the square root of -1. So let's go back to this question over here. You remember how we had, what was the square, here let me write I is equal to square root of -1. You saw that how square root of -25 we couldn't do it. So let me actually get a nice new piece of paper. Let's take a look at this. If I have square root of -25 and I know that I is equal to the square root of -1, right? Notice how else can I show the square root of -25? I could show that as square root 25 times square root -1. This is a true sentence, right? I could break this radical into like this. But do we know what the square root of 25 is? We do. It's 5. Do we now have a definition for what the square root of -1 is? We do. It's I. So now we know that the square root of -25 is 5i. And it'll be very helpful to solve other concepts within math. So just for example, if I said, hey, what's the square root of 36? This is 6. But what is the square root of -36? This would be what? 6i. And here, this will give us the idea of complex numbers. And I'll have that in the next lesson of what it means to be a complex number. And here we had the natural numbers, right? We're going to finish the lesson right now. We had the natural numbers, the integers, the rationals, the real numbers. And the final set of numbers for the course are complex numbers. And what it means, the precise definition of a complex number within this set, I'll have in part 2. I'll see you then.